In this video, we're going to write a computer program that works for both the 65C02 and the 65816. On the screen right now, you can see the properties I've got of two shortcuts on the desktop to the same X16 EMU Rev48. Both of them have this RAM 2048, which you absolutely need to run the editor. The Joy one is nice if you've got a gamepad you want to program with that. Zero RAM is also nice to have, but not strictly necessary. One of them has Rockwell, and that's the 65C02. The other one has C816, and that's the 65816. So we're going to write the code in the 65C02 one that I've got here. Let's just quickly load up the editor. It works on either 65C02 or 65816. And so let's just go right ahead and get into it. We'll set a label, text, and I know that the home key is 9.3. Let's just go back up and go to F5. Okay, so that's correct. And we'll go hello world. And I can see that this is 14 characters, so we'll go string 0E. And now we got to print that string. So we'll set another label, hello. And we'll load X with the low byte of text. We'll load Y with the high byte of text. And we'll load the accumulator with the length of text. And you can see in the middle column there 0E, 08, and another 0E. And that's correct. Let's just go ahead and insert 2 bytes here. And you can see that the low byte changes. You make any change to the low byte, high byte, or the length of the label, and it will automatically change in your code. So the next thing to do is let's do a print string program, add a comment, and we'll store the X in 0 page. At 02, we'll store Y in 0 page. At 03, we'll transfer A to X and load the Y register with 0. And at this point, we'll load the accumulator indexed indirect indexed. That's minus 02. And that loads the accumulator with whatever the address at 0203 is plus Y. We'll use that value then in the kernel at the character out routine. We'll increment Y to get the next value in the string. We'll decrement X, and when X reaches 0, we're done. So we'll branch not equal. We'll go to the address 08 to B. And then we'll return. So let's execute hello. And we get hello world. Okay, so since I'm at the top here, okay, I'm just going to delete these two again. Okay, you'll notice this changed back to 0E. And the next thing to do is we'll have another string. Let's go F5 and we'll say this. CPU is a 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, another 14 byte string. So, and we'll set another label. And we'll repeat that. Same process. And we'll branch to the address print string. And it automatically figures out that it's a D9 branch. You can branch to an address in this and it'll just automatically figure out what the relative one is. It's shown in mode 2 as what it actually is in memory, but in mode 1 we get all this lovely extra stuff. So let's do a main program. And we'll jump to hello. return and jump to character out, and that should print a return after hello, this CPU is a. So let's execute main. Great. Let's go to basic for a second. BASC. Basic is now displayed as a string. Doesn't matter how long it is, the editor figures out how long that is and just displays it as if it was a string. So the next thing we have to do is we need two more strings that says the names of the CPUs. So let's set a label CPU1. It's a string, it's 5 characters long. And set another label CPU2, also a string, also 5 characters long. And if I go F5, now we can just enter what those are, 65CO2, 65816. Okay, the next thing we have to do is pick between the two of those strings, which one to display. So we'll set a label, pick. Let's go to BASC again. Okay, so here's our whole program. It's getting to be almost a page long. So F1, we'll pick, we'll clear carry flag. And at this point, we're going to switch over to mode 6. Mode 6 is 65816 with 8-bit accumulator and X and Y registers. There's 4 different modes for 65816. Mode 7 has a 16-bit X and Y registers. Mode 8 has a 16-bit accumulator. And Mode 9 has both 16-bit X, Y, and accumulator. But in Mode 6, they're both 8 bits, so we'll just go SEP number 01. This sets processor status register. Any bits that are 1 in the parameter get set to 1 in the processor status register. In this case, that's the carry bit. So let's just put a comment here. Sets C if 65816. So at this point, if carry is set, we can branch on carry set. We'll go 4. And let's look at this in mode 1. You can see that that SEP value is recognized as a 2-byte no-op. Same in mode 2. So let's go back to mode, let's go mode 6. There we go. If it carry is clear, we want X to have the low byte of CPU1, branch 2 bytes. And if carry is set, we want X to have the low byte of CPU2. At this point, both of those threads come back together, and we can load the Y with the high byte of CPU1, load accumulator with the length of CPU1, and we can jump to print string. Go to main. We still need to add a call to pick in here, so let's insert 3 bytes and jump to pick. So here's our whole program, and it extends beyond 1 page, so it's a good idea to save. We'll call it hello.prg. Yes. And we'll execute main. Hello world, this CPU is a 65CO2. You can see the number and B flags that we have on the 65CO2. So that's great. So now let's open up the 65816 version, and we'll just load hello, run it. In this case, all of our code's already entered, so we'll just execute main. This is the 65816, and we have the M and X flags, who both 1. So that's it. We've just written code that works in both the 65CO2 and the 65816, and feel free to use this. 18E201. If set, then carry set, then you've got a 65816. Carry clear, you've got a 65CO2. That's it.